Okay, so we're going to look at functions today in terms of how we do those in Python. So what we would need to do is get a blank code sculptor window open, and we're going to write some different functions. Now, a function is also called a method or a procedure in other languages. And what it is it's a set of commands or an algorithm or steps that we can define generally, and then we can use that as many times as we want. So the way that we start a function is with the keyword def. You can see it shows up in purple, and then we have to name it something. So I'm going to say add. And I have a colon at the end, and what you can see is it's lined up. The the cursor is now indented over. Anything in here will be part uh, function. Right? And I can just do this. I could say print 2 plus 3. And when I run it, nothing happens. And the reason why nothing happens is because we haven't actually used our function yet. So now I need to call the function add, and that's our terminology for it. We call it. We know that it's a function because we have these parentheses here. So when I do this, I'm going to get 5. And if I do it multiple times, so if I do add again, right, it's going to run through and it's going to go to that function 4 different times, and I get my results there. And if I change it here, so now it's 2 plus 5, what I'm going to see is it changes it all to there. Now, this isn't a really good way to talk about adding because I have to hard code in my values here, and I can't change anything down here. I want to really add a couple of numbers. So one way to do that is to, instead of having this be coded as numbers in here, is make them generalized what are called parameters. These are placeholder values. The way we specify that is within the parentheses here. So you say A and B are our placeholder values. Now when I run it, I should see an error because I'm using the function without parameters or arguments. You can use either term. And I need to give it some values. So what I'm going to say here now, I'm going to say 2 and 3. I'm going to say 1 and 6. I'm going to say 4 and 9. And, I'm sorry, 5 and 9. And let's say negative 2 and 18. So now what happens when I run this is the first time through 2 and 3 will become placeholders for A and B, the next time through 1 and 6, the next time through 5 and 9, the last time through negative 2 and 18. So now I run it and I can see I get all those different values there that are my function values. So that is really helpful because I have the ability to change things here, use my kind of general definition of the function up there. And it's a much stronger way to program. So another thing that I could do is instead of printing the values in here, it's sometimes helpful to return a value, which means the function is going to give me back this. So when I see this 5 over here, that was great. I printed it, but there's no way to use those things together. So let's say that I wanted to add all those values. So now when I run my program, nothing happens. Okay, and nothing happens because I haven't actually printed a result. So now I need to do is I need to print a result down here. So now I get the 5, and I can print this, and I can print those. So the advantage of this is, let's say that instead of having one print statement, let's say I want to use my function multiple times. So I want to add up lots of things. And so I'm going to add all of these numbers together. So now when I print it, what I should see is the result of all of those together. And there we go, I got my 42. All right. The difference is if I had printed here, what's going to happen on this one is when it tries to get the result of that, what came back, there's nothing that comes back. And its keyword within Python for that is this keyword none. So now I see I got the first two, but when I try to add them together, all right, so I try to take the 2, the 3, the 1 and 6 and add those values, there's nothing that comes back. All right, you say we have this none type. So what happens here is if I was to take these ones off, you're going to see obviously 2 print results. I have 2 print results here, and I have 2 things that are going to show up. The first is going to be within the function, and the second is going to be the return type from this. So now what we see is there's my 5 and there's my none. All right, so that's kind of the overview of how functions work. Where things get interesting is if we start to use functions in functions. So let's say I have a function to add, and I'm going to make another function. We define another function to square a number. I just need one parameter there, and I'm going to return the number times the number again. So now if I want to use that, I can the square of the addition of 1 and 3. So when I add 1 and 3 together, I should get 4, and then I'm going to square it, but I didn't spell it correctly. And I should get back 16. Now I can see that my parentheses here are matching up. So when I click my cursor there, the blue ones line up, means those are closed. When I click in here, those ones are closed. If I lose a parenthesis, we're going to see that we get a syntax error. We have a token error here. So I need to have those parentheses there. So now when I run it, there's my 16. And this starts to build those layers of complexity using our abstractions. So this idea that this is abstracting, we don't have to know how it works. We just know that it adds them, and we just know that this squares them. And then we can go from there. All right, good luck.